Hello students, welcome to my channel. We have started one section of mathematics trigonometry and we have done first three exercises, exercise 8.1, exercise 8.2 and exercise 8.3 from Ncert, right? So today I am going to discuss the next exercise, exercise 8.4, which is based on trigonometrical identities. So with the help of this video we are going to solve exercise 8.4, right, from Ncert. Now what we have in this trigonometrical identities, in this chapter we will come to know about relation between 6 trigonometrical ratios: sine, cos, tan, cosec, sec, cot. And what first relation says? It says when we do sine square of this angle plus cos square of this angle, then we will get 1. If this angle C is represented by a symbol, by a Greek symbol theta, then sine square theta plus cos square theta give you 1. Let me tell you one more thing. What do you mean by sine square theta? Sine square theta means sine theta whole square. Okay, it doesn't mean square of theta. It doesn't mean sine theta square. Sine theta square, it means that we are doing a square of angle. If we write sine 30 degree square, it means sine 900 degree. It will become 30 square, that means 900. So it will become sine 900 degree. Okay, so in trigonometry, when we do square of t ratios, sine theta into sine theta or cube or anything, we write power here. Okay, so sine square theta means sine theta whole square. Okay, now this is what we have as first relation in trigonometrical identities: sine square theta plus cos square theta equals to 1. Now if I want to express what is sine theta from formula number 1, okay, then we need to keep sine square theta in LHS, cos square theta will go to RHS and become minus sine square theta. And if I want to remove this square, if I want to find only sine, then what will happen? It will become root and it will bring plus minus at front. We know when square goes to RHS, it becomes root and it brings, right, and it brings what? It brings plus minus, right? So this whole thing will become positive if theta is acute angle. If theta is acute angle less than 90 degree. How can you say this? This whole thing, the value of sine theta will become positive if theta is acute angle. So if you know the concept from the previous exercise, from the exercise of standard angles properly, then you will understand that at every standard angles, 0 degree, 30 degree, 45 degree, 60 degree, 90 degree, if you see the value of all the trigonometrical ratio at these standard angles is positive. Sine 0 degree is 0, sine 45 degree is 1 by root 2. You will find in that table that there is no negative value. So it means that between 0 to 90 degree, if you find sine, cos, tan of any angle between 0 to 90 degree, the value of those trigonometrical ratio will turn out as positive. So we can say that when theta is acute angle, that is when theta is lying between 0 and 90 degree, lying between 0 and 90 degree, so in that case the values of trigonometrical ratios can never be negative. That is why here we have positive value. Sine theta is equals to root over 1 minus cos square theta. So in a triangle, if I consider a right angle triangle, this angle will always what? Acute angle, if I say. So I am going to neglect negative in all of the expressions. Okay. So sin theta is equals to root over 1 minus cos square theta. Similarly, if I want to express cos theta in terms of sin theta, then what we need to do? We need to keep cos square theta in LHS, sin square theta will go to RHS, and it will become 1 minus sin square theta. So it means if in a question, if we find 1 minus sin square theta, so in place of 1 minus sin square theta, we can write cos square theta directly. And what is cos theta then? Root over 1 minus sin square theta. As I already told you that I am going to neglect plus minus. Okay, only plus I will consider, as theta is, as I am considering theta is acute angle. Now proof of this result. What we have in LHS? Cos square sin square theta plus cos square theta. So sine of this angle is the ratio of perpendicular by hypotenuse. So AB by AC, so it will become AB by AC whole square. Similarly, cos of angle theta is the ratio of BC by AC, so BC by AC whole square, right? So it will become AB square by AC square plus BC square by AC square. So after taking LCM, we have this step. Now AC square plus BC square, perpendicular square plus base square give you hypotenuse square by Pythagoras theorem. So AC square cancel out, and we have 1. This is the proof of the result. Sin square theta plus cos square theta is 1. Now come to the next relation, next identity. Sec square theta minus tan square theta gives you 1. Sec square theta minus tan square theta is equals to 1. Now do the same thing. Express sec square theta in terms of tan theta. Then this tan minus tan square theta will goes to RHS, right, and it becomes 1 plus tan square theta. So in place of 1 plus tan square theta, we can write sec square theta. You need to memorize, you need to memorize all these boxes. That is why I have drawn box. So in place of 1 plus tan square theta, we can write sec square theta, and in place of root over 1 plus tan square theta, we can write sec theta. So sec theta is equals to root over 1 plus tan square theta. So if I want to express tan theta from this equation, so in order to express tan theta, what I will do, I will bring this tan theta from LHS to RHS. So minus tan square theta will become plus tan square theta. See, so sec square theta minus 1. If I bring this 1 here, it will become minus. So sec square theta minus 1 is equals to tan square theta. And what is only tan theta then? Root over sec square theta minus 1. So in place of sec square theta minus 1, we can write tan square theta. In place of root over sec square theta minus 1, we can write tan theta. If you memorize this one, and after solving many questions, this all will fit in your mind. Okay. So right now we have discussed about 4 trigonometrical ratios: sine, cos, sec, tan. Now we are left with 2 trigonometrical ratios: cosec, cot, right? So cosec square theta minus cot square theta give you 1. In formula number 1 we have plus, and in formula number 2 in the middle, and in formula number 2 and in formula number 3 we have minus in the middle, right? So cosec square theta minus cot square theta is. And one more thing is there, if you want to prove this relation sec square theta minus tan square theta equals to 1, then you need to do the same thing in the same way which I have proved formula number 1. Okay, you need to apply the same method. Now based on these 3 formulae which we have discussed right now, let me show you the exercise which we are going to solve. This one, exercise 8.4. Okay, so how many questions do we have in this exercise? You can see we have 5 questions overall with subparts. Okay, so let's start from the first one. Here we have the solution. So in number 1 what we have, express the trigonometric ratios sin A, sec A, tan A in terms of cot A. Here we need to express sin in terms of cot, sec in terms of cot, tan in terms of cot. So let's move with the first one, sec A. So how do we convert sin A? So how do we convert sin A in terms of cot? First of all, in such type of question, first of all you need to think what is the relation between the trigonometrical ratios. Here we are going to talk about cot. So what is the relation of the trigonometrical ratios with cot? I think one relation is there, that cosec square theta minus cot square theta gives you 1. That we know. So that means there is a relation between cosec and cot. So here we have here we have sine. So how do we convert, express sine in terms of cot? As we know, there is a relation between cosec and cot. So first of all, change sine into cosec, and we know sine is the reciprocal of cosec. So in place of sine A, we can write 1 by cosec A. And in place of cosec A, we know we can write root over 1 plus cot square A. See, here we have that cosec theta is equals to root over 1 plus cot square theta. So there in place of theta we have A. So in place of cosec A, we can write in place of cosec A, we can write 1 plus cot square theta. Okay. Now similarly, again we need to express sec A in terms of cot. So we know there is a relation between sec and tan, that sec can be written as root over 1 plus tan square theta or tan square A. So in place of tan square A, we can write 1 by cot, as they are reciprocal to each other. So after taking LCM, we have this one done. And the last one, tan, we know it is 1 by cot. Number 2, write all the other trigonometrical ratios of angle A in terms of sec A. So we need to convert sin A in terms of sec A, we need to convert cos A in terms of sec A, all the other trigonometrical ratios except sec. So let's begin with sin. Sin, we need to express sin in terms of sec. How do we convert? Now we know that tan is sin by cos. Tan is sin by cos. So we can write tan A into cos A, which gives you sin A. Now tan A we know it is root over sec square A minus 1. Right? And in place of cos A, we can write 1 by sec A. So this is what we have, sin A in terms of sec A. Now tan A. Tan A we know it is root over sec square A minus 1 from the formulae which I have given in the above. Right? Now what about cot A? Cot A is 1 by tan A. So tan A is root over sec square A. What is the reciprocal of this? 1 by this. Now sec A. Sec A we know it is 1 by sin A, and sin A we know this. So reciprocal of this give you this. Done. Question number 3. We need to evaluate these two, and you can see there is no standard angles. No standard angle we have. So what we will apply? We will apply complementary angles formulae. See, they are complementary or not? 27 and 63? Yes, they are complementary. 17 and 73, they are complementary. So start with 1. So change either this one or this one. So I have changed sine square 63 degree. So in place of 63 degree, can we write 90 degree minus 27 degree? And sine square 27 degrees as it is. Similarly, either you can change this one or this one. So I have changed cos square 73 degree. Basically we change those trigonometrical ratios with larger angle. With large angle. So here 73 degrees larger than 17, that is why. Basically, but you can, there is no hard and fast rule, you can change any one. Now in place of 73 we can write 90 minus 17. Now sine 90 degree minus theta give you cos theta. As a square here we have, so we have square, and in the denominator cos 90 degree minus theta give you sine theta. Now see, cos square theta plus sine square theta, cos square theta plus sine square theta. I am saying theta theta, but there is 27 degree and 17 degree in place of theta. So in the numerator we have 1 and in the denominator we have 1, and we got 1. I have given the reason as well, that sine square theta plus cos square theta is 1. Next one. So here we have this one. So again see, 25 and 65 are complementary angles. So I have left sine 25 degree as it is, and in place of 65 degree, cos 65 degree, I have written 90 degree minus 25 degree. Same thing I have done with sine 65 degree. Now cos 90 degree minus theta give you sine theta. Sine 90 degree minus theta give you cos theta. So see, sine 25 into sine 25 is sine square 25 degree. Cos 25 into cos 25 is cos square 25 degree, and again sine square theta plus cos square theta is 1. Hence proved. Here we are required to evaluate, not prove. Okay, done. Now let's do question number 5. It's very important, no? Question number 5. So in question number 5, what we have in first of all, what we are required to do, prove the following identities where the angles involved are acute angles for which the expressions are defined. So here theta is acute angle, as all the formulas are there. We have neglect plus minus. Why? Because theta is acute angle. We are writing in place of sec cosec a root over 1 plus cot square a, we are neglecting minus. Why? Because we are assuming a is acute angle. Similarly in this question it is already mentioned theta is acute angle. So in the first one, what we have, we will do sums like LHS and RHS, right? So cosec square theta minus cot square theta, we are required to prove this. So see, here we have cosec cot, but in the proof we have cos. So with the first one, what we will do, we will change this into sine cos. How? We know cosec theta, in place of cosec theta we can write 1 by sine, right? In place of cot theta we can write sine by cos, sine theta by cos theta, right? So we will apply those things. Here we have the solution. Number 1. So in LHS we have cot theta minus cot square, cot theta minus cot theta whole square. So see, I have changed in sine cos. In place of cosec theta there is 1 by sine theta. In place of cot theta we have cos by sine theta. Whole square is there. Now take an LCM. Sine is the LCM, and since we have whole square here, so that square will become power of sine and will become power of numerator, 1 minus cos theta whole square. Okay. Now you can see the RHS. RHS is 1 minus cos theta by 1 plus cos theta, only with cos theta. There is no sine theta. Then what I will do with this sine? What is the relation between sine and cos? In place of sine square theta we can write 1 minus cos square theta. You might be thinking, sir, how will we understand? Right? That where we need to put the formula? You need to see the RHS, nothing else. In RHS there is no sine. All the things are in cos. So that is why you need to convert this sine into cos. And you know the formula. So apply that. Now here a square minus b square. What is the formula of a square minus b square? A plus b, a minus b. 1 minus cos square theta means 1 minus cos theta into 1 minus cos theta. So this cancel out. We have RHS proved. Question number 2. We have cos a by 1 plus sin a plus 1 plus sin a by cos a. We need to prove this one as 2 sec a. So first of all, what we will do? Obviously we will take LCM, and after taking LCM, what will happen? We will have cos square a and this one as whole square, 1 plus sin a whole square, right? So see, here we have the solution, number 2. So after taking LCM, we have this. Now expand this one by using the formula a plus b whole square. Now see, if I bring this one, if I keep cos square a with sin square a, what it will give? It will give 1. Cos square a plus sin square a is 1, and already 1 is already there, this 1. So here we have 1 plus 1 and 2 sin a is as it is. Now this one gives you 2. So we can take 2 common. What we will get within the bracket? We will get 1 plus sin a. Now 1 plus sin a cancel out. What is left? 2 by cos a, which is 1 by cos a is sec a. So 2 sec a. RHS proved. Number 3. Tan a by 1 minus cot a plus cot a by 1 minus tan a. We are required to prove this. What we will do? We will convert sin cot tan into sin cos. Here we have LHS. This one. So tan a is sin theta by cos theta and cot a is cos theta by sin theta. Written. Take in the LCM in the denominator. Now what will happen? This sin theta will multiply with numerator, and this cos theta will multiply with denominator, and same thing will happen with this term. So we will get next step. When this sin theta multiply with this sin theta into sin theta, we will get, which is sin square theta. And when this cos theta multiply with this numerator, we will get this. And similar thing is done with this term. Now again take the LCM. See, here we have sin theta minus cos theta. Here we have cos theta minus sin theta. So if we do this one as sin theta minus cos theta, one minus will come, and plus minus, this plus minus will become minus. So in the middle we will have minus. And this is the this is sin theta, okay, not sec theta, sin theta. So after taking the LCM, what will happen? This full thing will be divided by the numerator, this one. So only sin theta will left. So when sin theta will multiply with the numerator, it will become sin cube theta. And similarly we have cos cube theta. Now what is the formula of a cube minus b cube? The factorized formula. What is the formula? A minus b, a square plus ab plus b square. But I have written sin square theta cos square theta here. Why? Because sin square theta plus cos square theta is 1. Now see, this cancel out. We are left with 1 plus this full term is 1. Sin square theta plus cos square is 1. So 1 plus sin theta cos theta. Now what? RHS came? No. Now what we need to do? Now separate the denominator. When sin theta will become denominator of 1, so it will become 1 by sin cos. So 1 by sin theta into 1 by cos theta is what? Sec theta into cosec theta. And when sin theta cos theta will become denominator of cos theta sin theta cos theta, so they will cancel each other and it will become 1. Simply what I have done, I have separated the numerator. If we have an expression like a plus b divided by c, whole divided by c, so we can write now a by c plus b by c. So similar thing has done. Now number 4, here we have 1 plus sec a by sec a. So separately we will simplify LHS and RHS and we will prove this. Now in this question I am going to take RHS first. See the solution. So in question number 4, what is RHS? Sin square a by 1 minus cos a. Right, and we need LHS which is only in sec, and sec means reciprocal of cos. So first we need to change sin square a in cos, which is 1 minus cos square a, and again 1 minus cos square a means we can apply a square minus b square formula. So a plus b minus b give you this, and again this cancel out. We are left with 1 plus cos a, and in cos a we can write 1 by sec a, and after taking LCM we have RHS. Done. Now number 6, see the proof. Here we have the question. Root over 1 plus sin a by 1 minus sin a. So what we will do in this question? See the solution. We will rationalize the denominator. In the denominator we have 1 minus sin a by 1 plus sin a, right? 1 minus sin a by 1 plus sin a. So rationalize the denominator means we will multiply numerator and denominator with 1 plus sin a. So 1 plus sin a into 1 plus sin a give you 1 plus sin a whole square. And there in the denominator we have a plus b minus b, which is a square minus b square. Square root cancel out. So in the numerator, see, now 1 minus sin square a gives you cos square a. Square root cancel out, so we have 1 plus sin a by 1 plus cos a. Now again separate the denominator. Cos a will become denominator of 1, and again cos a will become denominator of sin. So 1 by cos a give you sec a, and sin a by cos a give you tan. RHS proved. Question number 7. Sin theta minus 2 sin cube theta by cos cube theta minus cos theta. We are required to prove this equals to tan theta. In the numerator we have sin theta common, in the denominator we have cos theta common. See, so after taking common sin theta from numerator and cos theta from denominator, we have this term. Now see, let me tell you, this two term we have now, 1 minus 2 sin square theta, 2 cos square theta minus 1, both are same. How? See, in place of 1, can we write 1 plus sin square theta plus cos square theta? Can we write in place of 1 sin square theta plus cos square theta? See, so I have written sin square theta plus cos square theta, again sin square theta plus cos square theta. Since here we have minus, that is why here we have minus here. Now see the simplification. Sin square theta minus 2 sin square theta give you only minus sin square theta. 2 cos square theta minus cos square theta, only cos square theta. Now both is same, cancel out. Sin by cos give you tan. RHS proved. Now number 9. So let me show you number 9. Cosec A minus sin A in one bracket, sec A minus cos A in one bracket. What we will do? We will convert this sin cos into sin cos. We know cosec A is 1 by sin, sec A is 1 by cos. So we will do like that. So in place of cos A we can write 1, in place of cosec A we can write 1 by sin A, in place of sec A we can write 1 by cos A. See the LHS. After that I have taken the LCM. So 1 minus sin square A by sin A, 1 minus cos square A by cos A. 1 minus sin square A is what? Tell me. It is cos square A. Right? 1 minus cos square A is what? It is sin square A. So after cancelling this one with this power, this one with this power, we have sin A cos A. Right? We have sin A cos A. Now don't do anything. Leave these LHS sin A cos A. Okay? Leave these LHS into sin A cos A. Leave this LHS into sin A cos A. Now bring RHS. Write RHS. Break this sin. Break this tan A and cot A into sin cos. You will get LHS. So don't do this. Okay. After this step, write RHS, and in RHS you have tan and cot. In place of tan A you can write sin A by cos A. In place of cot A you can write cot A by sin A. Now take LCM. In the denominator it will become sin square A plus cos square A, and in the numerator it will become sin A cos A, and we know sin square A plus cos square A is 1. You will get this one. Okay. Now the last one, question number 10. What we have in question number 10? So we have 1 plus tan square A by 1 plus cot square A in one bracket. First we need to prove this one is equals to this, and then this tan square A. So let's do. Here we have. We are going to prove both of them as tan square A. So we know that 1 plus tan square A is sec square A, and 1 plus cot square A is cosec square A. And we know that sec square A is 1 by cos square A, and 1 by cos square A is sin square A. Sin square A. Now sin square A by cos square A is tan square A. First part proved. Now consider this one. Right. We need to convert this into tan. Only tan. So what we will do with this cot? In place of cot we can write 1 by tan. In the numerator take this LCM. Take the LCM. Tan A is the LCM, and after taking this taking LCM tan A, it will multiply with numerator. It will become this. So this cancel out, and we have only tan square A. When we write this one, 1 minus tan square A, 1 minus tan A whole square, if we write this one as tan A minus 1, within the square nothing will happen, minus will become plus. See, that is why we have this one. So hope you have understood all the formulae in trigonometrical identities, sine with cos, sec with tan and cosec with cot, and I do hope that you have understood how I have solved this exercise. So your task is to do all the rest of the questions whatever we have, and you need to practice all those questions as well which I have solved by your own. So if there would be any doubts, please do ask me. Thank you for watching, and in the next video I am going to solve the last exercise of introduction to trigonometry from Ncert, and that last exercise is based upon application of trigonometry. It's very interesting, height and distance. You will enjoy that session as well. I do hope so. Thank you.